All right, class, I'm gonna continue with the recording for, I'm gonna continue with the recording for chapter 12, section 2, power rules for exponents. So I was in the middle of a recording and I was in the middle of a problem number 3 on page 235. And then somehow I lost connection into my Zoom and it never connected me back. It just ended it and claimed it was an error. So I think that recording will go through and process, but I had to make a new Zoom recording to continue that. So I'm going to share my document camera with you and then pick up on that problem. Okay, so when I got interrupted with that problem, I was on page 235 of our workbook. And this is section 12.2. And it's called power rules for exponents. And then this is where I left off, and then the Zoom got disconnected and just, ended the recording. So I had to start a new recording. So I'm going to pick up where I left off. So we're on page 235, number 3. So I was telling you that we were using the rule for power of a quotient. So you can see how your teacher was multiplying each inner exponent with the outer exponent. So I did that, 1, 2, 3, 4, 5. There's like 5 factors. There's like 5 factors, right? 1, 2, 3, 4, 5. So I did that 5 times. 1, 2, 3, 4, 5. And each of these get multiplied by 4. So they each of these exponents on the inside get 4 times bigger, basically, right? And then, so this is the result, the product. After I multiply, this is the result. And then I was telling you that I used the calculator on 3 to the 4th. That's a value of 81. So I can come over here and put that 81 there now. And the x to the 8 is fine where it's at. And the y to the 12 is fine where it's at. But in yellow, now I'm going to use the rule for negative exponents. Basically, what that rule is, you relocate and you remove the negative on the exponent. So you relocate the base and then you remove the negative on the exponent. Okay, so like this x to negative 4, that comes to the bottom. And you remove the negative on the 4. And then this y to 12 goes up to the top. And it doesn't matter if you put it in the front or in the back, but it goes up to the top and you remove the negative on the exponent. Okay. And then now going back to 12.1, because this idea was from section 12.1. And then there's another idea from section 12.1 is now you want to use the product rule. So the product rule says that a to the m times a to the n is a to the m plus n. You keep the base and you add the exponents when you're multiplying powers with the same base. And that's what we're doing. We're multiplying these powers that have the same base of y. We're multiplying these powers that have the same base of x. So we want to add those exponents. So 12 plus 12, and on the x, 8 plus 4. Okay, so that's us using the product rule. 12 and 12 is 24, and 8 and 4 is 12. Okay, and then I should be able to box that. Okay. Okay, and then that takes care of page 235. Okay. All right. Okay, now let's go to page 236. Okay, so this is the remaining problems on page 236. Okay. All right. So again, if you look at number 5, there we are using the rule for power of a quotient. Okay, so I'm going to put a little 1 on the 3 and a little 1 on the A, but the B doesn't need a 1. The B has it's been assigned an exponent of -2. Okay, and again, we're going to multiply, and multiply. So for the 3, I have 1 times 3. For the A, 1 times 3. And for the B, it's -2 times 3. But you see, all the inside exponents are getting multiplied times 3, and they're getting 3 times bigger. Okay, so on the 3, 1 times 3 is 3. On the A, 1 times 3 is 3. On the B, -2 times 3 is -6. And then we are going to use the calculator on the 3 cubed. So 3 times 3 times 3. 3 times 3 is 9. And then 9 times 3 is 27. So I'm going to just double check that on the calculator. 3 raised, so I'm using this key, to the 3rd power, and then enter. See, it's 27. 3 times 3 times 3. Okay. And then I'm going to replace that right away. And then the A cubed is fine where it's at. But then I'm going to highlight this in yellow, be the -6. And I'm going to use one of those rules from 12.1. I'm going to use the rule for negative exponents on that one. So if the negative exponent is in the negative exponent is in the denominator, so then I'm going to relocate it to the numerator. And then when I do that, I be sure to remove the negative on the exponent. So then that B to the -6, that B goes to the top, and then you take off the little negative on that. Okay, and then you're done. You'll be done with that problem here. Okay, and then if we do number 6, notice how I'm going to do this as an aside. See this part right here? I'm going to do that part as an aside because it's the only one that has that outer exponent of 2. Technically, these have an outer exponent, but they all have an outer exponent of 1. So that's why they're fine where they're at. But this one, I'm going to do a little aside. And I'm going to figure out what that is separately. And that 3 has an imaginary 1 there on it. And so I'm going to be multiplying, right, the inside exponent with the outside exponent. So I'm going to do 1 times 2, and on the A, negative 1 times 2. So 1 times 2 is 2. On the A, negative 1 times 2 is negative 2. And then I'm going to use my calculator on 3 squared means 3 times 3, which is 9, A to negative 2. And I'm gonna substitute. I'm gonna substitute that over here. So I'm gonna scratch this off, and I'm gonna put 9 A to negative 2. And so I'm gonna say don't rewrite it as 9 over A squared. Even though these are equivalent, this does become 9 over A squared, but we're not like in our final answer. Like if we were in our final answer, then I have to do that because you can't leave final answers with negative exponent, but we have a lot of work to do, see? So that's why you just leave it like this, and it's not a final answer, okay? So then now, when I come over here, now when I see this, I'm going to multiply my coefficients. So now I'm basically going to use in 12.1, I'm basically using the product rule. That's what I'm doing. So I'm doing 6 times 9, because remember we scratched this off. So I'm looking at 6 times 9. And then on the A, I'm doing 2 plus negative 2. And on the bottom, I'm doing 17 times 3. And then on the B, I'm doing 3 plus negative 1. Okay, so I am using the product rule for that. And then 6 times 9, 6 times 9 is 54, and 17 times 3 is 51. So 6 times 9 is 54, 17 times 3 is 51. And then on the A, and also, by the way, this can probably be reduced. We can probably reduce that probably by 3 in a little bit. We'll do that. But meanwhile, on the A, 2 plus negative 2 is 0. And on the B, 3 plus negative 1 is 2. Okay. And remember, by definition, remember that by definition, remember that a to the 0 is equal to 1. Okay. So, so we're gonna take care of that. I'm also gonna reduce this by 3 while I'm at it. Okay, so 54, I'm pretty sure 3 goes into that. 54 divided by 3 is 18. 51 divided by 3 is 17. And then a to the 0 power is 1. And then you have b squared. And then 18 times 1 is just 18 over 17, and then b squared. It's on the bottom there. Okay. So it's 18 over 17 b squared. Okay. And so that's what that problem simplifies into. Okay. Right. Okay, now let's see. Okay, if I look at, we have true and false statements. Let me look over these true and false statements. And then I'll probably go back and look at 233. Oh, okay, let me actually, before I do the true and false statements, there is another rule I want to add to 12.2. Better do that now before I forget. Let me do that before I do this. Let's go back to 230 and let's add this one to the bottom. And I'm going to just put a rule. So this is page 230, and I'm going to just say, I'll put a star. This is another rule. I'm not sure what to call it. They have titles. They'll have titles. It's kind of like this one, but it's got parentheses, a to the first power over b to the first power, close parentheses, raised to the negative n. So the way how this is very similar to this rule of a power of a quotient, but this n has a negative n. So you invert. See, b first changes place, right? A1 changes place, you relocate, and then you remove a little negative on that. So what we're doing is we're relocate the bases A and B, and then we're removing the negative on the n. Okay, and you're kind of familiar with relocate and remove, kind of familiar with that. Okay, and so that's what I would apply to this. So this example is actually like that. See this? Increase this. That's kind of like this. See? So what happens here, you want to catch that. See, you want to see that this would be y to the 5th over x cubed, and then you take off the little negative on the 4. See? And then you just continue now. You just multiply 5 times 4, and on the x, 3 times 4. 5 times 4 is 20, and 3 times 4 is 12. See that? And then there's another example of that. Let's see. On page if you go to page 233. And if you look at number 9, look at number 9, increase that. So remember I have a teacher's edition. So these are the answers, no work. But look at this. See, that's just like that. So this one would be y cubed over 2 to the first power x squared y to the first power. And then you remove the negative on the 4. Okay, so you see your teacher interchanged these. We swapped these, relocated them. And then I just put little ones, because there's a 1 here and there's a 1 there. And then I took off the negative on the 4. So that's using this idea. Relocating the bases and then removing negative on this outer exponent only. Okay, and then now we're gonna multiply. So this is 3 times 4, 1 times 4, 2 times 4 on the x, on the y, 1 times 4. Okay, then actually multiply 3 times 4 on the y is 12. On the 2, 1 times 4 is 4. On the x, 2 times 4 is 8. And on the y, 1 times 4 is 4. And of course, you want to use your calculator on 2 to the 4th. 2 times 2 times 2 times 2. So 2 raised to the 4th power. 2 times 2 times 2 times 2 is 16. So this is y12 over, and that 2 to the 4th becomes 16. X to the 8th, y to the 4th. Okay. Okay, and then this is interesting because what happens on that, and let me double check, I didn't notice that happening anywhere else on the other problems. I didn't notice that happening, but this is actually a good problem to show you because look what happens here. See this right here? That's going to require you to use I get that from 12.1 notes. That's going to require you to use the quotient rule. Use the quotient rule. Use the quotient rule for exponents, okay? And so that means that this becomes on the y, it's top, remember it's top minus bottom, remember? Top exponent minus bottom. So on the y, you're going to do 12 minus 4. And then you still have the 16 on the bottom and the x to the 8 on the bottom. But now you're doing 12 take away 4. And 12 take away 4 is what, 8? So that becomes y to the 8th. And you still have 16 on the bottom, and you still have x to the 8 on the bottom. Okay. But that would be the result for that problem there. Okay. Okay, and then let's see, I'll do 8 and 10, and then I'll go back to the true and false, and then we'll call it a wrap. Okay. So I go back to 8, and this is on page 233. Again, this is the answer. I have an answer key, but this X has a 1 and this 2 has a 1. And so we're multiplying. So on the X, we're doing 1 times 3. On the 2, we're doing 1 times 3. 1 times 3 is 3. On the 2, 1 times 3 is 3. And then you're going to use your calculator. 2 times 2 is 4, times 2 is 8. So on this, you're using your calculator. 2 times 2 is 4, times 2 is 8. That's 2 cubed. I can show you that here. You have your 2. You raise it to this power, and then you hit enter. Okay. Okay. And then 10, that's supposed to be the answer when we're done with 10. But 10, you see this part? This is like number 9. See, you're going to have to swap these and then take off the negative on that first. So this is going to become 6 to the first, a to the negative 4, b cubed. And then what's on top goes on the bottom. 5 to the first, a to the fourth, b to the negative 2, all in parentheses. And then that negative 2 becomes a 2. Okay. So basically, that gets replaced. That becomes this, right? And then this stays the same. So if you wanted to, you could like scratch this off if you wanted to. You could scratch that off and then replace that here if you wanted to. Yeah, we could do that instead, kind of like what we did with the other problem. So we could, we did that one time with one of the other problems that we scratched something out and we did like a little aside. We can actually do that for this one. We just scratch this off and then just relocate these and then take off the negative, take off that negative. Okay. So then what? Let's see. Well then, okay, maybe I shouldn't have whited that out because now we have to do a little aside for those. Yeah, so what happens is we're going to multiply all these, all these are going to get multiplied. Okay. Even down here, all of these are going to get multiplied. Okay, so let me start doing that. I'll just sit here. So on the 6, you're going to have 1 times 2. On the A, negative 4 times 2. On the B, 3 times 2. And same thing on the bottom. On the 5, 1 times 2. On the A, 4 times 2. On the B, negative 2 times 2. Okay. And the same thing's happening here on this side. The 5 has a 1 on it, but all these are getting multiplied. Same thing on the bottom. All of these are getting multiplied. So then you have this. And then on the 5, 1 times 3. On the A, 3 times 3. On the B, 4 times 3. On the 2, -2 times 3. On the A, -2 times 3. On the B, -2 times 3. Okay. All right, so then now when I start multiplying all that out, on the 6, 1 times 2 is 2. On the A, -4 times 2 is -8. 3 times 2 on the B is 6. 1 times 2 for the 5. 4 times 2 is 8. The B, -2 times 2 is 4. Okay, on the 5, 1 times 3 is 3. On the A, 3 times 3 is 9. On the B, 4 times 3 is 12. On the 2, -2 times 3 is -6. A, -2 times 3 is -6. On the B, -2 times 3 is -6. Okay. Okay, and then you can use your calculator. We're gonna use our calculator, and let me highlight that in pink, purple. So we can use our calculator on this, and this, and this. This one's interesting. This one, what we should do is move it to the top and then use the calculator on that. That's interesting. So let me see. Let's see. Let me use the calculator on all the other ones. Let's see. Like 6 squared is 36, right? 6 raised to the second power is 36. 5 raised to the second power is 25. 5 raised to the third power is 125, right? Okay, so when we write those, and maybe I should, let me put this here, use calculator. Really sure where to put all that. I have a heap more room. My goodness. Okay, so 6 times 6 is 36. 5 times 5 is 25. 5 times 5 times 5 is 125. Okay, and what's going to happen with this is going to go on top. So this 2 to the -6 is going to go on top. So what happens, I guess I can do that here. If I scratch this off and then I move it to the top, and I can change my ink if that helps. And I put 2 to the 6th power. So I move it to the top, and then I take off the negative on the 6. So now I have 2 to the 6th power, which is 64. And now that's going to be, this is going to be 64 times, and this remember was 125. This is 64, and now this is 125. So it's a big number. 64 times 125, wow, is 8,000. Okay. Okay, now let's see what happens with the A's. I'm going to use the quotient rule. I'm going to use the quotient rule. There's a couple of things you can do. You can use a quotient rule, or you can move them all around. So, and then use the product rule. So you actually have a couple of things you can do. Let me use that instead. There's a couple of things you can do. So if you want, what you can do is like this goes to the bottom and take off the negative. This goes to the top, take off the negative. These go to the top and you take off the negative. So if you want to go that route, you can. And what you're doing is that's called using the rule for negative exponents. So when you're doing that, you're using the rule for negative exponents, and that might be easier for you to do it that way. So then on top, you have the b to the 6 is fine, and then the a to the 8th is fine, but these move. This goes to the bottom, take off the negative. This goes to the top, take off the negative on the exponent. Okay, so this got moved to the bottom, take off the negative. This got moved to the top, see, take off the negative. Then over here, the a to the 9 is fine, but this goes to the top. So a to the 6 goes to the top, take off the negative. The b to the 12 is fine, but now this goes to the top. The b to the 6 goes to the top, and then you take off the negative. So really nothing's on the bottom. Nothing, because this got to the top, this got to the top, even this went to the top, remember? So there's like imaginary 1. There's nothing really down there, okay? And then now you're going to use the product rule. Which means like you're gonna add the exponents, right? So now you're gonna add the exponents. So like you're gonna add these exponents and then add those exponents, add those exponents, add those exponents. So now you have b to the 10 and a to the 16. And let me also do this. Let me also do this. See that 8,000 and that 36? Let me go ahead and multiply those, get those out of the way and simplify them. Add it. So see the 8,000 times the 36? Let me go and get that out of the way. 8,000 times 36 is 288, comma 1, 2, 3. And on the bottom, by 25. And then when I divide that by 25, I get 11,000. 520. And I remember I had an answer key, I had an answer key, see, 11,520. So that feel good about that. So this is gonna end up being our final answer here. Okay, now, so we said this was b to the 10. And then on the bottom, a to the 16. And then 9, how much is 9 and 6? That's 15, right? 9 and 6. So 9 and 6 is 15, a to the 15. And then b, 12 and 6 is what, 18? B to the 18. Okay. Okay, so we already took care of this. This gave us 11,520. Now we're going to take care of these here. So I believe on here we can add these here. We can add 10 and 18. So so I guess let me see, on the B, it's going to be 10 plus 18, which is 28. And I think I saw it over here. Yep, see? Okay, and then we need to get a by itself, a to the first part. So let's see how they're getting that. So the way they're getting that is because you have a to the 15 over a to the 16. So let me see. What happens there is they're subtracting. I don't know how to where to write that. The B, they're doing, I know it's an A. We already got the B. We added the B, we already added 10, 18 to 28. But the A, they're kind of doing like 15 take away 16. So the A, I'm not sure where to put it, but the A, they're doing 15 take away 16. So you see, they're using like the, because remember this is kind of like that, right? So there's imaginary 1, but they're doing this part here, quotient rule. They're using the quotient rule on that. So they are using the quotient rule on that. And so they're doing top minus bottom, 15 minus 16. And 15 minus 16, isn't that a -1? 15 minus 16 is a to the -1. Yeah, because if I do 15 minus 16, 15 minus 16 is a -1. And then they're going to relocate that. That's going to go to the bottom, and you take off the negative. So then that goes to the bottom, and then you take off the negative on that. Okay, but the computer will not want you to type in the 1. The computer, you see, we want this without the 1. Okay. All right, so that was a doozy. That was kind of tough, right? Okay. All right, but we got it done on video. Okay, now last thing we're going to do is the true and false. And last thing I want to tell you is just on page 231. On page 231, they have a summary. On page 231, they have a summary of all the rules from the very beginning. It looks like all of these. Looks like all of these are section 12.1, and then all of these are section 12.2 on page 231. So that's a good thing to know. You know how you can use a page of notes. So if you condense it, that would be a summary of all the notes so far, right? From 12.1 and then 12.2. So just FYI. Okay, and then let's see. Last thing we're gonna do is these true and false values. Let's just go over these true and false. On page 232. So it says taking the reciprocal of a fraction changes the sign of any exponent in the fraction. And they say that's true. So taking the reciprocal of a fraction changes the sign of any exponent in the fraction. Okay, well, I guess I didn't really think about that much, but I guess they're kind of talking about this. Maybe when we flip these, and then we did change the exponent on that. Maybe that's kind of what they're talking about, maybe, but they are saying that's true. Number two, for any exponent to refer to -7 as the base, -7 must be in parentheses. Okay, yeah, that would be true if you had -7 to the second power, and you know how your teacher puts base, exponent, and then evaluate, right? You've seen your teacher do that. Well, to say that the base is -7 means you need to have it in parentheses. That would be the base because it's in print, and the exponent is 2, and that would be -7 times -7, which would be 49, right? And if I type that in the calculator, parentheses right here, and then the negative here, -7, close parentheses. And then if I raise it to the second power, I can do that, or I can do that. If I raise it to the second power, it gives you 49. Okay. Number 3, when simplifying an expression with exponents, the rules for exponents must be used in specific order or the answers will vary. Yeah, that's false. The rules for exponents can be applied in any order, resulting in the same answer. That's true. There's just not one set procedure for doing it. As long as you're not breaking the math rules, the rules of exponents, you can do it in different order. So like over here, I was saying when we were working this problem, I was saying just that long problem we were doing. Remember, we're doing this long problem over here. And I said, I was started off saying that we could use the quotient rule. I was going to do like, I was going to do here. I was going to say, oh, you could do here. You could do a -8, take away 8, remember? -8, take away -8, which would give you a to the -16, and then you would go from there and work, quotient rule, quotient rule. But then I decided, no, I thought what would be easier. What I thought would be easier would be to use the rule for negative exponents. So this goes to the bottom, this goes to the top, this goes to the top, this goes to the top. So I changed my strategy and I used this rule in this order instead of using I was trying to use, here I was thinking of using the quotient rule, but then I thought this was simpler. Okay, so I scratched that idea and I went this route. So that's what they mean. You can do things you know, answers will be the same. But the roots exponents, they can be applied in any order, Okay, and then the last one, number 4, the expression -8 raised to second power simplifies to -64. And they're saying that's true. Yeah, so here the base would just be 8. The exponent is 2. And when you evaluate, this is imaginary -1 times 8 times 8, which is -64. Okay. All right. Okay, that we're going to call that a wrap class. Okay. Okay, good luck with your study. So remember, if you need tutoring when you're working with your homework, remember we have Mathro, and then the college is providing every student enrolled in math at St. Philip's, at least. I don't know about the other colleges, sister colleges, but I know at St. Philip's, every student enrolled in math class, they have 300 free minutes of BrainFuse online tutoring, which is in their Canvas course. And so you enter through Canvas and they tutor you by chat and whatnot. And then you can work with them that way. Or in Mathro, we have all those tutors that they are either they're tutoring from home, right? Because of the pandemic. At some point, they'll be coming back on campus. When we come back on campus, they just encourage everybody to get vaccinated and to wear their masks because of all the deviants, right? Or variants, right? So they at some point will be coming on campus to work and tutor on campus. But if you need tutoring, you should see your tutors, the Mathro tutors or the BrainFuse online chat tutors. The BrainFuse is open, I believe, 24/7, where Mathro, I think, closes around 8 o'clock. And sometimes it's not open on the weekends. I think in the summertime, they're not open on the weekends, but in the fall and spring, they usually are open, like not Sundays, but Fridays and Saturdays, they are open. And so, but you can get tutoring from Mathro or BrainFuse online tutoring. That's 24/7. The Mathro link is in your Canvas course. So when you go to your Math 410 Canvas course, you go through your modules, there should be a module that says something about Mathro in there. And then there's a link, an active link. So you click on the link, it has their hours, and at the bottom, it has all the lists of tutors, and those blue links are their Zoom hours. So as long as they're working, you click on their Zoom link and they should let you in. As long as it's a day when they're working, then of course they let you in to their Zoom link. And then they have a capability, you can tell them, hey, I want to share my screen with you, or you know how to take pictures and PDF things, email things. There's different ways you can communicate. But if there's a will, there's a way, right? Where there's a will, there's a way, right? Is that the comment? So that you can get tutoring if you need it, okay? And hopefully the video recording will help. I do a lot of problems in the recording, so hopefully you looking at that will help you do it on your own as well. But if you need supplementary tutoring, please seek that out, okay? Okay, have a good one. Good luck with your studying.